algebra students, this video is going to be on our lesson, graphing from factored form. The goal for this lesson is that by the end, if you are given a quadratic equation in factored form, that you can create a graph of that equation. We've done some activities so far in class where maybe you're matching an equation in factored form with the graph, but in this lesson we're actually going to make the graphs ourselves. And we're using those words factored form here. So let's start with what we already know about factored form. Factored form looks like this equation right here. We said we know if something is in factored form if it's an equation written using that multiplication. So here, this equation is written x plus 3 multiplied by 1 minus x. It's also one of the two ways we can write quadratic equations. Some of the stuff we already know about quadratic equations is we know quadratic equations are always going to have x squared, or the other way we can write it, x times x somewhere in them. So for example, this equation, I see if I multiply it out, I see that x times x right there. And we've also already learned that quadratic graphs are going to look like this. We said they have this U-shaped curve to them, and we've learned we call that graph a parabola. So in this lesson, we're going to be learning how we actually create that parabola ourselves. In our last lesson, we learned something about factored form and what you know from an equation if it's written in factored form. Do you remember what that something is? We learned that factored form is really helpful with us knowing our x-intercepts. We learned the other form, standard form, is good if you want to know the y-intercept. But factored form, it's pretty easy for me to find the x-intercepts from factored form and where that graph crosses our x-axis. That is going to be important for today because if we want to graph an equation in factored form, the very first step we are going to do is we are going to find our x-intercepts. That's something we learned in a past lesson, so I would encourage you, pause the video here, try to find those x-intercepts, and then press play to check and see how you did. So in our last lesson, we learned if you want to find x-intercepts from factored form, it's going to be the two numbers we can use for x to make y equal 0. And we learned the way you do that is you just take each factor, each parenthesis, and make it equal to 0. So I would solve the equation x plus 5 equals 0, and I want to solve the equation 1 minus x equals 0. When you solve this first equation, you can just subtract 5 on both sides, and we have an x-intercept is at negative 5. To solve this equation, I can just bring x to the other side of the equation, and I've got an x-intercept at 1. In that lesson, we talked a lot about writing it with a pair of numbers. And so each of those x-intercepts is a point, and I could represent those points as negative 5, 0, and 1, 0. Already, this is good information for me if I'm trying to make this graph. So here's my graph, and I know there's going to be a point at negative 5 on my x-axis. So here's my x-axis. That's negative 1, negative 2, negative 3, negative 4, negative 5 right here. And I also know there's a point at 1 on my x-axis right there. So that's already 2 points on our graph, but notice this is not enough information. I don't know, does my graph go like this? Does it look like a smiley face? Does it go the other direction and look like a sad face? Is it really short like that, or is it a lot taller? I don't know enough information yet. So x-intercepts is going to be our first step, but there's more I need to do. I need another point on this graph. And that other point we are going to figure out is our vertex. We had talked about vertex in a past lesson. We go back up to those pictures of my parabolas. Your vertex, we learned, is either the lowest point or the highest point on the parabola. And so if I know where that vertex is, that will be enough information for me to draw my graph. For example, if I know the vertex is right here, then I know now where the parabola is. There's one other thing, though, we know about a vertex. We haven't discussed it yet, but it's something we've seen in a lot of examples. When you look at the location of the vertex, we've talked a lot about how it's the lowest point or the highest point, but notice it's always in the middle. We don't have parabolas that look something like this, right? Where that vertex is off to the side. It's always in the middle of the parabola. So what that means for my vertex is the vertex is going to be in the middle of our x-intercepts. My vertex is going to be somewhere right here in the middle of -5 and 1. So when we find our vertex, it's going to end up being a point on the graph. But I know that x-coordinate is going to be in the middle of -5 and 1. Now sometimes it's really easy to see what the middle number is. For example, if I asked you what number is in the middle of 2 and 4, I think most of us know the middle number is 3. For -5 and 1, it might be a little harder for you to identify what that middle number is. So something you can always do to help you find the middle number is take an average. And when you're finding an average, it just looks like you adding those two numbers together and then dividing by 2. And so the middle number of -5 and 1 would be -4 divided by 2, which is -2. And if you think about our number line, I can use a graph as our number line. -1, -2, that's right here. And I can see on that graph that that's going to be in the middle of those two x-intercepts. So that lets me know my vertex is going to be at -2. My vertex is going to be somewhere on this dotted line that I'm drawing. Again, though, that's not enough information. I know the vertex is going to be our highest or lowest point, but I still don't know. Is it down here? Is it up here? Is it all the way up here? I still don't have enough information, and that's because I still need the second number of my vertex. I need that y-coordinate. And so the final part of this, we know the x-coordinate is -2. I need to find that y-coordinate for my vertex. And the way we do this is the same way we've done it for a lot of different equations. If you know the x and you want to find y, all you have to do is substitute. In your equation, replace x with -2 and then solve, and it'll tell you what y is. So what that looks like for me is our equation is y equals x plus 5 times 1 minus x. I need to solve y equals x plus 5, so x is -2 now. So I'm going to say -2 plus 5 times 1 minus x. X is -2, so it needs to say 1 minus, be careful, you need a second one, 1 minus -2, right there. And this is the math we need to do. Why don't you pause the video and make sure you can do that math to get our y-coordinate. So for this equation, it would say y equals, well, -2 plus 5. It's the same thing as 5 minus 2. That's 3. And then for the second one, 1 minus -2, we've learned minus a negative is the same thing as adding. So 1 plus 2, which is 3, and 3 times 3 is 9. And so that second coordinate for our vertex is 9. Now I have all the information I need to help me finish graphing this. My vertex is going to be at -2, which we already said is right here, but it's at -2, positive 9. So I go over to -2, and then I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is another point on our line. Now that we have all three of these points, I've got the two x-intercepts and the vertex, now it's a lot easier for us to see where that parabola is, where that graph is. It's going up through this x-intercept to my vertex, and remember it's a curve, so I'm trying not to really draw a straight line, and then through that other x-intercept. So it looks something like this. So these are going to be our steps. This first one is review. This is what we did in the last lesson, was finding our x-intercepts from factored form. The new part is step 2, finding that vertex. And what we're seeing is to find your vertex, you need, in order to find the x-coordinate, you're finding the middle of your two x-intercepts, which we said you can do this average over here if you need. And then to find that other coordinate, the y coordinate, you are just substituting the x coordinate into your equation and solving that to find that y. I've got 2 other practice problems that we're going to do in this video. That way, when you finish the video, hopefully you're feeling confident about doing this yourself. These steps right here, these are going to be important to put in your notes. That the first thing you want to do is find your x-intercepts, and then second, you want to find the vertex by doing this. So if you have not copied that yet into your notes, go ahead, pause the video, and do that now. And then after you've done that, here is the first practice problem. So in order to graph this equation, the first thing I want you to do is find the x-intercepts. Go ahead, pause the video now to find those x-intercepts from this equation, and then come back to check and see how you did. I went ahead and I got it started for us. So we said to find the x-intercepts, you're setting each factor equal to 0. So for here, the 2x minus 6 in parentheses, I set that equal to 0. And then our other factor is just x. So that one's already solved for us. That one's going to be x equals 0. If I solve our first equation to help us find the x-intercept, I can add 6 on both sides. That gives me 2x equals 6. And then I divide both sides by 2 to get our x-intercept is at 3. So from this right here, I know there are 2 x-intercepts. There is one at 0, so that would be right here. And then our other x-intercept is at positive 3. So 1, 2, 3 is right there. That's our first part. So similar to what I did here in the blue, I'm just setting both parts equal to 0 to find those 2 x-intercepts. Now, just like up here, that's not enough information. If all I am looking at are those 2 points, I don't know what the graph looks like. So the other piece of information I need is the vertex. On the homework and the tests and in your future educational life, you might just see questions like this where that ask you what the vertex is. And in order to find the vertex, these are the same steps you would do. You'd find your x-intercepts, and then our second part, what we did here in purple, is what helps us find the vertex. We're doing this to help us graph, but you might just have a question that asks you what the vertex is, and you'd do the same thing. So for our question, where is the vertex? We know the same stuff we knew up here. I know it's in the middle of those x-intercepts, so I need to figure out where the middle is between 0 and 3. Sometimes people don't like this, but there is a number in the middle of 0 and 3. It's just a fraction or a decimal. And so for this next step, I want to find the middle of 0 and 3. And if you need to find the average, you can by doing 0 plus 3 divided by 2. That's 3 divided by 2, which gives you 1.5. There's nothing wrong if your vertex is a decimal. It just means over here on my graph, I'm going to have to estimate. 1.5 is like about halfway in that box right there. So my vertex is somewhere on this line here. Now, 1.5 is not a vertex. If I asked you where's the vertex and you say 1.5, that's not 100% correct because a vertex is a point. And so there's going to be 2 numbers, just like before. What I know right now is I know the x-coordinate. Because it's between our 2 x-intercepts, I know the x-coordinate is 1.5. Go ahead, pause the video, and try to find what that y-coordinate is now. So the part up here that's still on the screen, this is how we did it earlier. To find that y-coordinate, I'm going to take our x, 1.5, and I'm going to substitute it into our equation here. And so my equation is y equals x, and we're using 1.5 for x. So x times 2x, so I need 2 times 1.5 minus 6. So we get y equals 1.5. 2 times 1.5 is 3, so we get 3 minus 6. And y equals 1.5 times, well, 3 minus 6 is negative 3. And then finally, 1.5 times negative 3 gives us negative 4.5. And so our vertex is at 1.5, negative 4.5. And so now I have all of the information I need if I wanted to graph this quadratic equation. I'm going to go over to 1.5 where I was already, and I'm going down to 4.5. So that's 1, 2, 3, 4 full boxes, and then halfway. So I've got my vertexes in that point right there. Now again, looking at this graph, I've got all of the information I need to draw my parabola. It's going to go through one of those x-intercepts down to our vertex and then up here. I think it would be a little better if that was a little more curved, but I'm doing my best. I've got one final practice problem, and this one, the numbers are going to be a little bigger. Notice that y-axis on our graph, I needed a graph that had larger numbers, but I want you to pause the video and try this one yourself. I know some of you watch this video and don't pause, but it's really important that you're pausing to get that practice before you get to like a homework or a test. So go ahead, pause the video and try to do all of the steps you need in order to graph this equation, and then come back to the video and check and see how you did. So now that you've tried it, we're going to go ahead and go through the same steps to graph this equation in factored form. We said the very first thing we need to do every single time is find the x-intercepts. And so in order to find our x-intercepts for this equation, you set each factor equal to 0. So I'm going to do 11 minus x equals 0 and x plus 7 equals 0. When you solve those equations, this equation here is going to give you x is 11, and this other equation is going to give you x is negative 7. And so your two x-intercepts are at the points 11, 0 and negative 7, 0. That is helpful because now I know 2 points on our graph. I know there's going to be a point at 11 on our x-axis, and so we've got this line is 4, which means each line is 2. So 0, 2, 4, 6, 8, 10, 11 would be halfway on that box. And then negative 7, it'll be similar. Each line is 2, so that's negative 2, negative 4, negative 6. So negative 7 would be right here. Now, if you had different numbers for your x-intercept, that messed you up for our second step where we find our vertex. So if you had something different up here, I would say go ahead, pause the video now and see if you can fix the rest of your graph. For that last part, we need to find the vertex, and we need this information to help us do that. So if you did not have 11 and negative 7, pause the video here and try to finish it yourself. Okay. We said to find the vertex, I need these numbers, 11 and negative 7, because our vertex is in the middle. It's going to be in the middle of 11 and negative 7. And to find the middle of those, we said you can add those two numbers. So 11 plus negative 7 divided by 2, that gives me 4 over 2, which is 2. And so I know the first part of my vertex. I know that x-coordinate is 2. I think it's always good when you're finding that middle number just to come to the graph and check. So for example, in the past, I've had students who make a mistake somewhere here and maybe get, like I know I've seen 9 in the past as the middle. But if you come over to the graph and check, 9 is right here. There's no way 9 is in the middle of those x-intercepts. And so that's a good extra step to do just to make sure you've got the correct x-coordinate. So if I come over to my graph, my 2 is right here, and yep, that is in the middle of our 2 points. For the last part, I've got my x-coordinate is 2. To find the y-coordinate, to find this number right here, I need to substitute. And so our equation was y equals 11 minus x. So y equals 11 minus 2. And then times x plus 7. So x plus 7 would be 2 plus 7. And so when I go to solve that, 11 minus 2 is 9. 2 plus 7 is 9. And so then our answer, 9 times 9, is 81. And so for this graph here, my vertex is going to be at 281. When I go to graph that then, I'm over here at 2 on my x-axis, and I have to go all the way up to 81, which is why this y-axis, the numbers are larger. 81, this line right here is 80, so 81 is going to be just a little bit past it, maybe right there. And now I've got 3 points. That's enough for me to graph. Don't forget, to finish your graph, you do have to draw the line. So the graph is not just these 3 points. We finish by drawing that parabola. And so our parabola, it's much wider this time. It's going to look something like that. And that is everything. So we said our goal for this lesson was by the end, if I give you an equation in factored form, you can come up with the graph of the quadratic. So this parabola right here. The homework is going to have similar questions where it asks you questions about how to find the vertex and then how to graph equations like these. Thanks so much for watching this video. I hope you found it helpful, and I'll see you in the next one. Bye, y'all.